Okay, we are live now. Nice to see you, ma'am, after so long. Huh? Little bit sound here and there will be there for some time. Just bear with that. Now, today I'm going to start fourth chapter. So, in force and laws of motion, there are some things we are going to understand that we need to know. Now, first work is, what is the meaning of force for you? Can you explain what is the meaning of force for you? What is force? Push or pull is considered as force. So if somebody will ask you that what is the benefits of force, can you tell me what are the benefits of force? Yes. Good evening, Siddharth. What and all are the benefits of force? First, you tell me. So, if somebody will be, good evening, beta. So, if somebody will be asking you about force, what is the first answer it is coming from you, which you will be exactly trying to explain to everyone? That what is the meaning of force for you and how it is exactly coming for you, force. Okay. So, how you are going to explain force? Come on, say it fast. So, I've shared the link in the group. Harish, camera little down you have to go. Otherwise, your face, everything is coming there. Okay. Yes, that's a very cool answer. So Siddharth has given answer. So look here. So if somebody will be asking you this question that what is the benefits of force, then what answer you are going to give? Out our work and done by using force. Yes. In absence of force, yes, we can say that force is one thing which drags us to do work. In absence of that, we can't do work. Correct now? In absence of that, we can't do work. So force is something which is exactly telling us to do work. That's the very cool answer you have given. Can you tell me what and all are the benefits of force? If anybody will ask from you, what and all are the benefits of force? If somebody will ask you, what answer you are going to give? Come on, say this. In absence of force, force gives us motion. Absolutely correct. You people are sitting idle. You need to answer some of the questions like what are the benefits of force? If somebody will ask you, what are the benefits of force? Good evening, beta. So can you tell me what and all are the benefits of force? If somebody will be asking you the benefits of force, what answer you are going to give? So you need to answer some of the questions which I'm asking from you. The benefits of force. Come on, type and say the answer. What and all are the benefits of force? So if somebody will be asking you about benefits of force, what answer you are going to give? Come on. So one answer Siddharth is given that force has given us motion. So force gives us motion. That's one of the coolest answer I got. Another benefits of, see, look here. From the morning you are waking up. In absence of force, in absence of energy, you can't be doing any work. Correct now? So if somebody will be asking you that, okay, what and all are the benefits of force, then you will be saying, Auntie, there are many benefits of force. I am dragging myself by applying external. Yes, I know that. I'll explain that one. It will be very helpful. So now listen here. So when somebody will be asking you, you can answer it in this way, like ki force means our internal energy that will drag us to do some work, like lifting, jogging, eating, working. So whatever work we are doing, that will be just explained as force. Now another question I need to ask from you, like balanced and unbalanced force. So in this chapter, what and all we are going to study is, the first part we are going to study is effect of forces. So what and all effect a force is generating? Okay, can I stop and slow down the speeds? Yes, can I stop and slow down the speeds? Yes, that's also we can talk about. Now listen, so if somebody will ask you balanced and unbalanced force we are going to study, then we are going to study Newton's laws of motion. Newton has given 3 laws of motion. Ma'am, I am in class 10. Then in which week you will cover the chapter control and coordination? Yes, I'm going to explain control and coordination very soon, beta. And exactly, I'm starting control and coordination part already over. One more time revision I'm starting. Today maths, coordinate geometry I'm going to teach in evening. Morning tomorrow I'm going to teach you length chapter and refractive index and all. That's a very huge topic. You must cover that part. Now look here. So inertia, force, and conservation of momentum. These are the three parts we must discuss. Okay. So now shall we start our next work? So the principle of dynamics, we are going to understand something like what if somebody will be asking you, the principle of dynamics can be wrapped up in the neat package of three fundamental or basic statements called as Newton's laws of motion. So we are exactly, see, Newton's laws of motion are the three basic things which are exactly, which is very, very important for us to understand. Okay. Newton has given three laws of motion, the three fundamental laws, which is exactly very, very important for us. So now we will discuss that one also. But before that, we will understand what is the meaning of force. Understood? What is the meaning of force? So first we will understand for what is force. So according to that, I'm giving you a definition. Force is a push or pull. Force is a push or pull which changes or tends to change the state of rest or uniform motion, direction of motion, or shape and size of the body. So actually the force can change the shape, size, and also the direction of the body. Shape, size, and direction of the body. Now shape, size, and direction of the body, when I'm talking about, what does that mean? Can anybody explain it? Online children, anyone can explain it? What does the meaning of direction change? What is the meaning of push or pull? Shape change. Force can also change shape. It can also change what you call push or pull is also a type of force. Shape change is also a type of force. Now who can explain in just can you say me fast? Say fast. So if somebody will be asking you about push pull, I told you that we know that force push pull is also a type of force. Then change of shape is also application of force, and direction change is also application. So everywhere we are seeing force. Chahil, are you there in the group? So everyone, just first say me hi, the students, those who are present there, so that I can start my work. Please come on, go for it. Till now, what did I explain? I talked about force. Understood? What is force? Any type of push or pull is considered as force. The push or pull is doing certain works. What are the work push or pull is doing, beta? See, the object can either be moving towards the source which is dragging the content, understood or not? So if I'm having a suitcase, I am pulling the suitcase. So 100% the suitcase will come towards me, understood? Now I'm having a box and I'm pushing the box outside, means away from me. That means what? The box will go away from me, correct now? So that means what we have seen here is the push or pull will exactly let the body go away or near. I hope you might have understood. So that push or pull will exactly let the body go near or far. Understood? So it will take the body near or let the body go far. Understood? So this is exactly one thing. Now, direction change is also there. Now, one example I'm giving you, just tell me, is the example apt for you? The example what I'm giving you is when I have to change the direction, like I am going to my house and I have to turn left. So for that, if I will keep my vehicle straight, will I be able to go my house? No, definitely I am going some other house. Understood? So what I have to do? I have to apply force to change my direction. Understood? So if I am in a vehicle, Bhavya, it's very late. So if I am in a vehicle, that means the vehicle direction will change. The vehicle direction will change. So you need to understand that any type of push or pull is considered as a part of force. Any type of push or pull is considered as a part of force. Understood? Now force can change the direction. Force can change the shape of the object. Like I'm having a balloon, and what I did is I squeezed the balloon. Will the shape of the balloon be changed or not? Can you say me? The shape of the balloon will be changed or not? Yes, the shape of the balloon will be changed. So when the shape of the balloon is changed, that means what? It is associated with what? Force. Because you have applied external energy. This external energy is nothing but force. What is this external energy? Force. This external energy is nothing but force for you. I hope you might have understood this one. So we learned about force. Now we are going to talk about push or pull. So if somebody will be asking you about push or pull, let's check this one out about the push or pull. So if somebody will be asking you about the push or pull, when we push, the object will go away from you. The object will go away from you. When you pull, the object will go near to you. Understood? So pull means the object will go near to you. Push means the object will go away from you. Did you got this point? Push or pull, did you understood? So push or pull will let the body go either away or near. Now another important point to be noted that force is an interaction between two objects or between an object and its environment. That's the most important thing. If somebody will be asking you that what is actually force associated with, then what answer you are going to say? Is it connected with the environment, beta? Is it connected with the environment? Yes. So we need to understand that force is exactly not a small term. The force usage is very, very high because the nature is also applying force on you. Have you ever experienced the force of wind? The force of wind, did you experience? Have you ever experienced the force of rain? Yes. Thunder force? Yes, your friend is pulling you, your friend is pushing you. Did you experience force? You are picking something. Did you experience force? You are going in a lift. Did you experience certain force? Yes, Bhavya, that's absolutely correct, beta. So give some examples. Online children, can you give some examples of force, please? Type and send me some examples of force. And offline children also, can you explain? I gave these many examples of force. Now, I wish to get some examples of force from you. Can you tell me? Muscular force, absolutely correct. So, there is a term called as muscular force, muscles. Very good. Next. Yes, so actually, when you apply any force, like the force what you are applying from your hand, hammer, that means what? You are actually using your energy to exactly do some work. Understood? Friction is opposing force. Very good, beta. Friction is also a type of force, but friction is not a force which help. It is a type of gravity force. Very good. So Bhavya has given two important answers. First answer, she talked about gravity. Gravity is also a type of force. Correct, na beta? Friction is also a type of force. So friction, gravity, are they opposing force or are they helping force? Friction is opposing gravity. So if something has to fall down, the object will fall down near the earth or it will go up. So that means what? And muscular force she talked about, understood or not? Mechanical, we can use it. So that's some points you have given and it's very good. So we are going to just change the topic. We are going to go to the next part. So force is an interaction between two objects. 100% to experience force, two objects has to interact. Understood? Sometimes the objects are meeting each other and then they are experiencing force. Very good, correct only. Sometimes the object is exactly meeting each other and then they are experiencing force, and sometimes they are not meeting and then they are experiencing the force. Are you understanding? So magnetic force is the two objects coming near. You need to understand magnetic force is not like that. You need to answer my question about it. Did you experience magnetic push or pull? Magnetic push or pull, did you experience any time, beta? How many of you have experienced it? If you tell me, see, muscular, frictional, gravity, very good. Very good. Back to back, you have given correct answers. But I'm just asking another question. Shahil, if you're there in the group, Tanisha, if you're there in the group, I want to know these answers, please. So I want to know about, sometimes some forces are contact force, some forces are non-contact force. Understood? So which forces are contact force? Which forces are non-contact force? Very good. Say. See, if you all will say one time means I won't be able to understand that. You need to say it one by one. Can you tell me one by one answer, please? Huh? Okay, magnetic forces are contact or non-contact. So if the lines of forces are present in the magnet, what they do is either they will attract or they will repel. So for from far only. But muscular force means if somebody will slap you, to experience that pain means the slap has to reach your face. Understood or not? So that's a contact force. Correct now? So very good. Frictional force is also a type of contact force. So when contact will be there, then only you can see opposing force also. You cannot drive the car on air. Understood or not? So that means what the friction is exactly the tires are experiencing friction because the tire is exactly in contact with the floor. So when the tire is coming in contact with the floor, then only that friction is exactly experienced. I hope you might have understood this part. Everyone, clear? Absolutely clear? Say, come on, say, is it clear? The concept is clear? Is the concept clear here? Very good. So you have understood the concept. So any type of push or pull is called as force. Force can change the direction. Force can change the shape. Okay. Afterwards, I'll ask one question. Just one question came in my brain. I just thought like, okay, fine, I should ask, but now I'll not ask. Afterwards, I'll ask that question. So force is a vector quantity or a scalar quantity. Force is a vector quantity. Force is what? Vector quantity. Force is not a scalar quantity. Force is a vector quantity. Understood? Second is with magnitude and direction. So force is having magnitude as well as direction. Force is having what, beta? Magnitude as well as direction. Force is having magnitude as well as direction. So force can change the direction also. So electrostatic force is also there. Very good. Very good. Nice way. Now listen, I want to know about SI unit of force. We must know that SI unit of force is Newton. SI unit of force is Newton. Understood? So Newton sir has exactly, we are talking about the SI unit of force in terms of Newton. Understood, na beta? All of you understood this part? So SI unit of force is it a vector quantity or a scalar quantity? Force can change the shape of an object? Yes? Okay. This force is changing the shape of the object. I'm taking a bottle and I'm trying to change the shape of the object. Is it going to change? That means, is my force sufficient enough? No. The force has to break the inertia of the object. The force has to break what? Inertia of the object. Inertia is the incapability of a body to change its state of rest or motion until and unless, Arshita, hello beta. So until and unless, see, an external force is applied on it. But the thing here is, the most important part you must remember here is, when we are talking about force, the force must be, or the energy must be higher to distort the shape. Understood? So if it is not there, the work will not be done. Understood? Bhavya, you did not understood beta. Which part you have not understood? Can I explain it one more time if you have not understood? Okay, so what I'm talking about is, see, when we are applying force, right now I have explained the different type of forces. I explained you that force can change the direction, force can change the shape or size of the object. Just like one simple example I'm giving you, that one spring. So if I tie something on the spring will exactly, after some time, the spring elasticity will be distorted and the object will exactly little bit go down. Understood? So that's the work of that. But I'm not talking about that. See, many times I cannot change the shape of this bottle. Why I cannot change the shape of the bottle? I am applying force, but it is not enough to change. But beta, if I am applying force here, I am able to open the, yes, cap of the bottle. So what is the difference between two? I cannot apply, I cannot change this, but I can open it. Why? Sufficient force is there. That's cool, but that's not the complete answer. Come on, let's see. Think very nicely, because real physics is not in book. Real physics in the concept, or real physics in what you are learning from nature. Understood? So just try to answer that question. Try to answer that question. Come on. You can do it. Think nicely. Some object shapes can be changed. If I want to push a wall, will the wall be moved by me? Can I move a wall? But I can easily move a pen, a lid, and everything. So if I want to move, I am moving it. So why it is so that I can move some things, but I can't move something until I'm applying force in both the things. I'm applying force in both the things, but one thing I can move, one thing I can't move. What is the difference between the concept in both the things? Tell, because you must understand that. Sham, can you think I can't lift something, I can lift something. I can lift this one, but if I want 100 kg, I can't lift. Why? What is there which will not allow me to do that work? What is there which will not allow me to do that work? Shweta? Mass. Are you understanding? First one is mass. Got it. So if mass is more, because force is equal to mass into acceleration. Got it. So first I'm talking about lifting or pushing or pulling. If the mass is more, means I need more force. Correct now? But beta, if I will keep this in a down of train track, definitely it will just flatten out. Correct now? So it will flatten out if I will keep in somewhere where very heavy force is applied. That means the mass has to be super. That means the mass has to be disturbed. That means the mass has to be overcome. Understood? If we can overcome the mass, or if we can overcome the mass, or if we can overcome, another important part is particle composition. Particle composition, that time the cap is not sealed under pressure. Okay, that I can take. I will not say that you are not wrong, not fully correct or fully wrong. Actually, this is one thing. So cap is not fully sealed under pressure. So pressure application is one part where force is exactly, pressure is equal to force by area. So pressure also is connected with force. So you are not wrong in that. Okay. But I am still waiting for a perfect answer. And you people can do it. Think nicely. Bhavya, you can give the answer. Think about it. Today, Chahil is not joined. Chahil is not there. I'm looking forward some very important answers. Come on, think and answer. Mass is one of the part. I explained about mass. Mass is one of the part. So mass content I have already explained. Mass is more means more force will be applied, because force is equal to mass into acceleration. Understood? So mass is one of the factor. Another factor about solid object is I can change the shape of sponge, but I cannot change the shape of bottle. Why? The particles are exactly having internal force of attraction. Understood? First, we have to disturb that force of attraction. The particles are having there, so two particles are tightly packed together. They have high internal force of attraction. We have to disturb that force of attraction. Then only, means if the force of attraction is weak, we can change the shape. But if force of attraction is very heavy, we cannot change the shape. So that's called as internal force of attraction. So here in the steel particle, the particles are exactly cricket world. The particles are tightly packed. Since the particles are exactly having high force of attraction, so we cannot be able to remove it, or we will not be able to change its shape so easily. Understood? So we have to first overcome its force of attraction, then only we can think about its change. So we can melt it by applying high heat. Understood? So if we are applying high heat, we can change its shape. I hope you might have understood. Come on, did you understood what answer I gave? Can anybody explain it back, please? Yes, intermolecular force of attraction in the solid particles are strong. So since the intermolecular force of attraction between the solid particles are strong, it is yes. We cannot change the shape so easily. I hope you might have got this point. Come on, say children, did you understood here? Offline children understood, correct? So now online children understood why we can change the shape of some objects and why we can't change the shape of some objects. Okay. Okay, fine. So we will be doing the next work. Let's see. Now, can you explain me what is this? Um, Muscular force, I can understand. Contact force, I can understand. But actually, what is happening here? Change of direction. Here, change in shape is not there. Change in direction. So, object is actually strategy. Nice. So, change in strategy. Huh? So, change in direction it is there. Ma'am, window open, ma'am. Window open, ma'am. Let Fine. Just 1 minute disturbance is there. Just okay. I'll explain it. Just 1 minute. Done. Now listen. Can I go get back to work, please? Just 1 minute. Wait. Shall I start, beta? Fine. So that means change in direction is there, not change in shape. So now kicking a football, it's what? Change in direction. Pushing a car. Now we are going to understand about it. When we push a ball lying on the ground, it start rolling. That means the force exerted has thus produced motion. So external force applied on an object is producing what? Motion. External force applied on an object is producing motion. External force applied on an object is producing what? Motion. Understood? So now another part is, however, when we push a heavy stone, it will not move. That's the concept I was asking about, that if we can apply force, some objects will move, and if we are applying force, some objects are not moving. Understood? Why, beta? Because the motion is not there because of mass. Because of mass. So we need to first exactly understand inertia. Understood? So at the time when I will be discussing about inertia, that time I will explain why it is moving and why it is not moving. I hope you might have understood this part, huh? So now we will go for the next part. Done. Fine, little bit work is going on, so only a little problem is there. Just 2 minutes. Yes. I'm just asking one question. A batsman, when hit the ball is exactly going near you. Will you try to catch the ball like this or like this? Which position is the best one? Can you catch the ball like this or catch the ball like this? Which one is the most safest position for you, and why? Will you able to catch the ball like this, or you be able to catch the ball like this? Huh? So why you are exactly like, how many are cricketer here? Who is playing cricket? Hmm. So at that time when you are playing cricket, exactly what is your strategy when you have to take the ball? What and all work you have to do that time? Are you just increasing the time gap to catch the ball, or you are wanting to catch it as fast as possible? As fast as possible means force of that ball will be very heavy. You might have seen that when a batsman is exactly hitting a ball, the person who is going to catch the ball, they are taking more time gap, they are taking more time gap to go there just to pick the ball. Understood? You might be seeing that they will not be catching like this, they'll not be catching like this, they'll keep their hand more down and then they are catching it. The time gap is increased now, so pressure will be little reduced. Understood? The force will be little reduced, impact will be little less. But sometimes when you are very near and you are trying to catch it, that time only pain will come in your hand. Understood? Because we know now that there is an exchange of energy. Got it? That also part we are going to discuss. But right now just check this one out. A ball falling under downward can be easily caught by our hand. The motion of the ball has thus been destroyed. However, a big piece of rock rolling downward hill cannot be stopped. Even we are trying our best to do it. First is the force, the speed with which it is going. So there is a word called as velocity and there is a word called as mass. Mass and velocity changes. Understood? A very big stone is coming towards you. Will you try to catch the stone? Come on, say. Will you try to catch the stone? No, 100%. You will say go. You will run away. That time, this can you put it here? Harish, don't close it. Put here. I need for charging. Uh, Shanvi, are you there in the group? Now work done. Hand down. So I hope you might have understood this part. Yes. Shanvi is not there in the group. Okay, fine. Now look a bit up. Shall we go back to our work, please? Huh? Now without disturbance because work is over. Now we can start. Now listen bit up. So we need to understand that some objects we are trying to move and it can be movable. Some objects we are trying to catch also. That means it depends upon mass and velocity. It depends upon its force of attraction between the particles. There are certain things we need to understand. Force can change the shape, force can change the size, force can change the internal composition. But we need to apply force or we need to apply energy more than their content. Understood? Otherwise, it will not be changed. I hope you might have understood. Can you give me an example where you can be able to change the shape? Come on, say. Give me an example where you can be able to change the shape. Balloon, absolute. Next one. Huh? Plastic water bottle, very good, fine. Shape change, come on. Go for example of shape change. Children, they have given offline, children has given the example. They are talking about change in shape. Balloon, one example I got. Plastic ball, paper, very good. We can crush the paper, huh? Rubber band also, elasticity, super, very good. Huh? Clay, very good. We can change dough, maida dough, and what you call dough also. When we are making wheat dough and maida dough, when we are taking, what we are doing, we can exactly change the shape. The clay also, we can change the shape. Bang, bingo. So they have given more examples. They have given more examples. Super. Now, very good. So that means we can change. But some things like which we cannot change the shape. Examples where we cannot change the shape. When we cannot change the shape. Rock, rock also we can change the shape. You might have seen that they are putting hammer and they are carving it into certain structure. So that is also force application. When they are putting force, rock can be changed its shape, but more force is required there. Understood? Another example, please. Come on, you can do it, huh? Huh? Titanium. 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 For what titanium? You cannot change the shape. Which shape cannot be changed. So exactly, force of application will be more, but shape will be changed. Huh? Iron, okay. We can also carve it, we can melt it, and we can recast it into whatever shape we are wanting. That's a good answer. Very good, super. The girls are exactly leading. So a balloon can become oblong or pressing between. So we can change the shape. Very nice. So you see here, compression and stretching spring can also change the shape. That's a very cool answer. Okay. Shall we go for the next one? Now we are going to talk about balanced or unbalanced force. So we need to understand that what is the meaning. Cable wire, very good beta. So when we talk about cable wire, can you say in an elaborated way, the cable wire due to extension also can change the shape. That's also cool, very good. So now look here, can we talk about balanced force? Can we talk about balanced force and unbalanced force? Can we talk about balanced or unbalanced force, please? Okay, ma'am, it will take some time. Six, because I started late, so I will be teaching till right now. It is 6 o'clock, na 6:15. I'll close. Solids, okay. Now, what is the meaning of balanced force? Does balanced force, any object kept at rest, is having a balanced force or unbalanced force? I kept a bottle after drinking. The bottle is not at all moving. The base is not controlled, so only it is moving. So it is what type of force? Balanced or unbalanced force? Huh? Balanced force. Okay, so that means what? Once the object is exactly kept in some location, the object is not at all changing its shape, its position. That's example of balanced force. Huh? The frames are kept in a specific position. It is not changing its position. So it's an example of balanced force. Very good, well done. So some things are exactly examples of balanced force and some examples are non-balanced force. That's very cool. Very good example. But still I'm not satisfied with the example. Online children, come on, give some very brave answers. Huh? Balanced and unbalanced. Balanced and unbalanced. Online children today leading with more answers. So I am really appreciating you people. Say balanced force. Any object kept at any position, when they will not change its position. Now see, He is trying to change the shape. That's an unbalanced force because he's applying the force and the object is exactly moving. So that's a case of unbalanced force. So when the force is applying, when the force is applied from all the directions, let's see, the normal is upward, force of gravity downward. If you are pushing, then friction is applied. That means the object is not moving. If the object will start moving, then it's an unbalanced force. At the case when the object will not move, means what I am doing is, I kept like this and I'm not, it's not moving. Means what? If I am just pushing the object is not moving, means the object is at balanced force. What is that? Balanced force. But if I am trying to push and the object started moving, so that time it will be called as unbalanced, because all the thing here is I am pushing, then normal force is going up, gravity, but that frictional force is overcome. I am overcoming what force? Frictional force. So the moment I am overcoming frictional force, a disbalance is generated and the object will start going towards one particular direction. I hope you might have understood this one. Come on, say, did you understood this part? So when I will apply some force and the object will not move, means the object is at balance. But if I am applying force and the object will start moving, means that time what I am going to say is unbalanced force. That time what example I am going to say it as? Unbalanced force. That's the example, or that's the difference between balanced and unbalanced force. Come on, did you got my point? Please say. Good. So for balancing of force, which and all things are needed? Normal, up, gravity, down, frictional, opposing the push. I hope you might have understood. Can you repeat with me? Down, normal. Normal is always perpendicular to the surface. Normal is always perpendicular. So we will say normal which direction? Normal, up, gravity, down, friction. So if I am pushing from this direction, friction will come from which direction? Opposite direction. Friction will come from opposite direction. Normal, gravity, friction, when I am pushing from this direction. I hope you might have understood. Huh? But if the object will not move, means mass is more and the object is in balance. It is due to inertia. Inertia. It is due to inertia. And if the object will start moving, means what is the example? Tug of war. Very good. Tug of war, we can take as an example where from two sides people are stretching the rope. Na? The one side which will apply more push, the objects will exactly start moving towards that side. That's again a very good answer indeed. Okay, now we will go for the next one, effect of forces. So what in all are the effect of forces? That's the first topic we are starting and we are talking about. So what we learned about force, can you tell me what in all we learned about the force? Can you say? First point, what we learned about force? Force is a type of push or pull. Force can change the shape, direction also. Very good, bingo. And after that, what we have learned about it? Super, very good. First time I'm hearing you children answering with so much confidence. That's what is needed. We did not touch the content, correct now? Force is a vector quantity or scalar quantity? Very good. SI unit of force? Super. You just saw it in one time and you learned it, correct now? So is it very good? You are learning nicely? Huh? So, and frictional force, opposing force or it is in the favor of force? Opposing force. Gravitational force, very good. After that, magnetic force, contact or non-contact? Bingo. So we learned many important points and then we have talked about balanced and unbalanced. In balanced and unbalanced part, we learned that if we are pushing or pulling the object, if the object is not moving, exactly the object is considered as what? Balanced. The object is considered as balanced. The object is considered as balanced. Okay. In the balanced part, what we have learned is that normal is gravity, friction. Understood? So frictional force will be opposing force always. I hope you might have understood this part. Now, effect of forces. What and all are the effect of forces? Force can bring an object to rest, or force can disturb the rest. Understood? That means what? An object is kept, like your mobile. One example I'm giving you. Your mobile is kept on table. Now it is at rest. What you did? You want to play in mobile. You will take the mobile. That means you disturb the rest. Your book is kept on table. You took the book. Now book was at rest. You disturb the rest part of. Understood? That's called as change in state of rest or motion. And again, direction. You want to go to your home. You will go left or right. So changing direction by application of force. Next is size of the object. We have also discussed about changing the size of the object. Like balloon we have discussed. So when balloon is exactly there, we are squeezing and changing the size of the balloon. Next, about the shape of the object, the speed of the object also we can change. Absolute. The speed of the object also we can change. How can we change the speed of the object? By increasing or decreasing the velocity, we can change the speed of the object. Is the class interesting? You are learning about force? Interesting or very boring chapter? Very good. So now we are going to talk about next. Direction already studied, shape already studied, speed already studied, rest motion, and then size. Bingo. We have explained all the important part, and that too plainly. We did not read line by line, but we have understood everything. Correct now? So here many content we have studied, and many content we have studied with in our own pace. Nobody stopped us. We studied in our own. Now we are going to talk about balanced and unbalanced force. So already we studied about balanced and unbalanced, interacting and non-interaction. Very good, Bhavya. This topic also we discussed. Now we are going to talk about balanced and unbalanced. The number of force acting on an object does not produce any change in state of rest or uniform motion. That time it will be considered as what type of? Balance. That time it will be considered as what, beta? Balance. We can talk about it as balance. That we already studied. Okay. Without definition we studied. Now, now they are writing definition. First we understood, then they are writing definition. Correct? So that means what? Physics is everywhere, and we are, nature study is nothing but physics. An application of formula is to make physics more practical. Are you understanding? Interesting, auntie? Yes, beta. Bhavya, you can do it now. Now listen, beta. So example of balanced force, when minimum or force equal to magnitude but acting in opposite direction. So unbalanced force and balanced force we have understood. So when the force are applied on an object change the position, shape, direction, then it will be considered as balanced or unbalanced. Balanced or unbalanced? Unbalanced. Because now it is exactly changing the, everything it is changed. Correct now? Everything it is changing. What and all things it is changing, beta? Position, shape, next. Everything it is getting changed. So that's why it is called as what, beta? Balanced or unbalanced, Amrish? Unbalanced. That time it will become unbalanced. Acha, can one example I'm asking from you? Okay, one example I'm asking from you. Just give this example. Sometimes you are exactly playing with your friend. You are playing with your friend and you exactly took lunch box and ate the lunch box. Is it a balanced force or unbalanced force? Is force there? What type of force is there? What type of force is there when you are exactly taking? So, muscular. See, that time when you are eating the lunch now, that time when you are eating the tiffin, that time no force is there. Just picking and eating, muscular force. But after that fight is coming now, that is real force of application. Because your friend is definitely going to punch you. Understood? That is, Sam is giving a serious sarcastic look. I didn't mean about punching anyone. Okay, fine. So actually, force is applied there also. Understood or not? Just example of force when your friend will punch you. That also is a type of force where punching is there. Understood or not? So you are getting beating. That beating is also a type of force. So can I keep it till here? We'll start. I have another class to start online. 30? How much marks you have devoted to your teacher?